Hello, this is Angelia, and you're listening to or watching the podcast, Why You Do What You Do. A podcast that deals with human development and psychology to maybe help you figure out a little bit more about why you do what you do. And last time we were talking about gender differences in aging. Us ladies, we usually outlive the guys, sorry guys. But, this is a thing. And, it's just a fact of life. Now you guys are catching up, but for now that's just kind of the way it is. And we're going to continue on that. Women in the United States benefited more than men from gains in life expectancy during the 20th century, particularly the reduction in deaths from childbirth. So that has gotten better, thankfully. And it's a rare thing that you have deaths in childbirth anymore. In 1900, there was only a 2-year gender difference in life expectancy. So the gap was a lot closer then. The gap widened to nearly 8 years in 1979. Since then, it has narrowed to about 5 1/3 years, 2 years less than the world average, largely because more men are surviving heart attacks than before, thanks to modern medicine. Because of the difference in life expectancy, older women outnumber older men nearly 3 to 2. And this disparity increases with advancing age. By age 85, the ratio of women to men is 2.5 to 1. Similar gender ratios exist internationally. Why people age? Hope of further lengthening healthy life expectancy depends on our growing knowledge of what happens to the human body with the passage of time. Early in adulthood, physical losses are typically so small and so gradual as to be barely noticed. Did you notice yourself aging in your 20s and 30s? Probably not really. With age, individual differences increase. One 80-year-old man can hear every word of a whispered conversation. Another cannot hear the doorbell. One 70-year-old woman runs marathons. Another cannot even walk around the block. That'd be me. I ain't that old, but I can't walk around the block. The onset of senescence, a period marked by obvious declines in both body functioning, sometimes associated with aging, varies greatly. Why? For that matter, why do people age at all? We were just talking in the Bible reading about because God gave us the curse because we disobeyed Him, and we only get to live till we die. Most theories about biological aging fall into 2 categories: genetic programming theories and variable rate theories. Genetic programming theories. Genetic programming theories hold that bodies age according to a normal developmental timetable built into the genes. And a lot of folks, subscribe to that one. Such a timetable may imply a genetically decreed maximum lifespan. Cells in the body are constantly multiplying through cell divisions. This process is essential to balance the programmed death of useless or potentially dangerous cells and to keep organs and systems functioning properly. Leonard Hayflick found that human cells will divide in the laboratory no more than 50 times. This is called the Hayflick limit, and it has been shown to be genetically controlled. So cells apart from the whole organism are only going to divide 50 times. So there is a pre-programmed limit to cell division. If, as Hayflick suggested at one point, cells go through the same aging process in the body as in a laboratory culture, with of course much different, because in the body it's still being fed, so they're going to divide more than 50 times in your body. There might be a biological limit to the lifespan of human cells, and therefore a human life. a limit Hayflick then estimated at 110 years. And, you know, the Bible says the years of man are 120, so he's not off by much. Failure might come through programmed senescence, specifically genes switching off before age-related losses. For example, in vision, hearing, and motor control, and we know those are the things that start going first, become evident. Or the biological clock might act through genes that control hormonal changes or cause problems in the immune system, leaving the body vulnerable to infectious diseases. There is evidence that some age-related physical changes, such as loss of muscle strength, accumulation of fat, and atrophy of organs, may be related to declines in hormonal activity. Once we go through menopause, things start settling, if you know what I'm saying. We also know that the efficiency of the immune system declines with age. Levels of immune cells production can predict 2-year survival rates among the oldest old. Another hypothesis is that the biological clock is regulated by a gradual shortening of the telomeres, the protective tips of chromosomes, each time cells divide. This programmed erosion may eventually progress to the point where cell division stops. Supporting an evidence came from a laboratory study in which the gene for telomerase, an enzyme that enables sex chromosomes to repair their telomeres, was injected and activated in human cells. The cells continue to divide well beyond their normal lifespan without apparent abnormalities. And I hope somebody is doing some research on this, so we can have like a serum or something to help us live longer. Raising hopes for a cure for diseases and disabilities of old age. A study of 143 normal, unrelated adults aged 60 and up found a link between shorter telomeres in blood DNA and early death, particularly from heart disease and infectious diseases. So maybe in the future doctors can look at that and say, oh, well, we need to keep a watch on this for you because you got this gene. I don't think we're there yet, but we should be there. Come on. Hayflick and his colleagues recently have challenged the existence of a specific, predetermined, and rigidly timed genetic program for aging and death. Instead, they say, genes that influence aging do so indirectly, as a byproduct of complex processes involved in normal growth and development. Even if genes do exert strong controls on lifespan and patterns of aging, genetic programming alone cannot be the whole story. Otherwise, all human beings would die at the same age, and as we know, we do not. Environmental and experiential factors must interact with genetic ones. Variable rate theories. Variable rate theories, sometimes called error theories, view aging as a result of processes that vary from person to person and may be influenced by both internal and external factors. In most variable rate theories, aging involves damage due to chance errors in or environmental assaults on biological systems. Other variable rate theories focus on internal processes such as metabolism, the process by which the body turns food and oxygen into energy, which may directly and continually influence the rate of aging. Wear and tear theory holds that the body ages as a result of accumulated damage to the system beyond the body's ability to repair it. I would say I have this problem. As cells grow older, they are believed to be less able to repair or replace damaged components. Internal and external stressors, including the accumulation of harmful materials, such as chemical byproducts of metabolism, may aggravate the wearing down process. So, the bad news is there's a genetic component for aging and death. And right now, there's not much we can do to stop it, but take care of ourselves. So, you know, all the bad stuff, eating too much sugar, too much fat, drinking too much alcohol, taking illicit drugs, you know, danger behavior, you know what I'm saying. You know, sports are all things that are going to tear you up and make you age and maybe die faster. And that's where I'm going to leave you for today. Hope this helped you figure out a little bit more about why you do what you do. Please like and share this educational program so we can spread it around the world. If you want to help me out, subscribe to my YouTube channel. If you want to help me out even more, go to my Patreon page and become a patron. Thanks for watching. That's all for now. Until next time.